Good afternoon, students. Welcome back to the class. This is the continuation of the previous class. In this class, we see some important results and points on the quadratic equations. So this is part 3. Part 3. Here is the first important point. If x belongs to R, then the maximum and minimum values of a plus x into b plus x whole by c plus x, where x is greater than minus c and a is greater than c, b is greater than c, or square root of a minus c minus square root of b minus c whole square and square root of a minus c plus square root of b minus c whole square. Next point, if the expression ax square plus 2hxy plus by square plus 2gx plus 2fy plus c can be resolved into two linear factors, then determinant A.H.G. H.B.F. G.F.C. is equals to ABC plus 2FG H minus AF square minus BG square minus CH square is equals to 0. Next, third important point. Different forms of quadratic equations. Direct and indirect forms. In this, the first subpoint, if a to the power of f of x plus b to the power of f of x is equals to A plus B and AB is equals to 1, then f of x is equals to plus or minus 1. Second point, if A into f of x whole square plus B into f of x plus C equal to 0, then put f of x is equals to t, which reduces to a t square plus bt plus c equal to 0. Now solve for t. Third subpoint, a to the power of f of x is equals to a to the power of n, then solve for f of x is equals to n. Fourth point, a to the power of f of x plus b to the power of f of x is equals to a to the power of n plus b to the power of n, then solve for f of x is equals to n. Fifth point, x minus a into x minus b into x minus c into x minus d is equals to a x square and ab is equals to cd, then put t is equals to x plus ab by x. Sixth subpoint, x minus a into x minus b into x minus c into x minus d is equals to a, and a is less than, b is less than, c is less than d. Also b minus a is equals to b minus c, then put t is equals to x minus of a plus b plus c plus d whole by 4. Next, seventh point, x plus or minus a whole to the power of 4 plus x plus or minus b whole to the power of 4 is equal to t, then put t is equals to x plus or minus a plus x plus or minus b whole by 2. That is t is equals to x plus or minus a plus b by 2. In general, square root of x plus m plus n whole to the power of 4 plus square root of x plus m minus n whole to the power of 4 is equals to p. Then put x is equals to minus m plus or minus square root of minus 6 plus or minus square root of 36 minus 4 n to the power of 4 plus 2p whole by 2. Next, third point, for 3 consecutive integers, a comma b comma c, the equation f of x is equals to x minus a whole square plus x minus b whole square plus x minus c whole square is equals to 0, has no real roots. Both roots should be imaginary and conjugate to each other. Next, fourth point. Any cubic equation of the form of the form x minus alpha whole cube plus x minus beta whole cube plus x minus gamma whole cube is equals to 0 for alpha comma beta comma gamma belongs to the set of real numbers, always possesses one real root and two imaginary roots as f dash x is greater than 0 for all x belongs to R. Next, fifth point. Let ax square plus bx plus c is equals to 0. A is not equal to 0. B comma c belongs to the set of real numbers. If the roots of the equation are real and distinct, then one root is more and one root is less than the average of their sum. That is, alpha comma beta are the real roots. Here alpha is not equal to beta of ax square plus bx plus c is equals to 0. Then alpha is less than minus b by 2a, comma beta is greater than minus b by 2a. Next, sixth point. A comma B comma C greater than 0, then ax square plus b mod x plus c equal to 0 has no real roots. No real roots. In this case, both roots will be imaginary and conjugate to each other. Next, seventh point. Number of quadratic equations which are unchanged by squaring their roots is 4, then the quadratic equations whose roots are 0, 0, 0, 1, 1, -1, omega, the set omega square, where omega is a imaginary cube root of unity. Imaginary cube root of unity. Next, if f of x is equals to ax square plus bx plus c equal to 0, have no real roots, and a plus b plus c is less than 0, then c is less than 0. So these are the important points, results defined over the quadratic expressions and equations. Since from the first part, second part and third part, this is the third part we have seen. So in the next class we solve some problems on the quadratic equations and expressions based on the formulas whatever we covered. Thank you.